The final topic in the King chapter is on unions. Unions are rarely used. I'm just going to mention them. We won't do any homework or write any programs using them. Right? They were used to save memory space. Right. So a union is a collection of variables that's similar to a struct, but you can only store information in any one field or any member at a time. So a union can have multiple members, but you can only store information in one of them at a time. Right, the memory that's used to store the variables can be of different types, so we can have ints, doubles, right, other types in there. You can have structs within there. Once a new value is assigned to that member field, the old data is replaced with the new data. Right? So the variable type can contain many different values, like the struct, but it only is going to hold one at a time. Simply, that means you can have multiple members, only one of them can have information stored in it at a time. And the compiler is only going to allocate space for the largest of the data members. So whichever one of your data members requires the most memory is how much memory will be allocated. Back in the days when C was first written and there wasn't as much memory, it was important sometimes to then use it as efficiently as possible, and that's why they created unions, and they were occasionally used. Well, not occasionally, they were used probably more often than what they are now. Now you might find yourself using one, say if you have an 8-bit microcontroller that has very small memory and you had a rather large program you were trying to put in there, right? And you were trying, if you had limited memory space, depending on what you were doing, you might consider using a union. Right? So members of a struct are stored at different addresses in memory, while the members of a union are stored at the same address. But I think when we see the next slide, it'll make this, what I just said, the words a little more clear. Right, so here we have a union. It has two data members. It has then I as an int, D as a double, and its name is S, right? We'll refer to this by the name S. If we create a struct that has two data members, I is a double, I is an int, and D is a double, and name it S, right? Notice everything is the same here except for union and struct. And actually, if I want to name these S, I should put the word typedef in front of them. It wouldn't both go in the same program. Right. Now let's take a look. Struct's data member I is going to occupy 4 bytes. So I'm assuming that an int is 4 bytes. So here's the struct's memory allocation. So the first 4 bytes go to I, and then the next 8 bytes go to D for the double. Right. So a struct is going to require 12 bytes of memory. But a union, even though the union has both an int and a double, well, the int requires 4 bytes, the double requires 8. So it will pick then the larger of the two, which is the double. So the union is going to use 8 bytes of memory. So the struct, if you were to allocate it, right, would take from address 200 to 211. But the union will only occupy from address 200 to 207. So 4 bytes less of memory. So the union saves some memory space. But because it uses the same memory space for both of these, but when you refer to I, it will actually store information, the union will, in 200 to 203. Right, which is why you can't store a double at the same time, because D also uses some of these bytes. So you can only store in one or the other with a union. With a struct, you can store in both. Like I said, the union was used just simply to save memory. You can initialize a union, right? So you can have some sort of designated initialization. Notice then when you initialize the union, since you can only store information in one of the members at a time, you only initialize one of the members. We can either initialize D, right, or we can initialize I, but not both. And you can assign to one or the other, similar to using this dot operator. So you do all the same things to get to the memory, right, to get to the members. So it works just like a struct in that way that you access the data members. You can have pointers to unions, things like that, right? The difference is union takes up less memory, so you can only store information in one of the members at a time. And as soon as you do, it overwrites what was in the other member. And you can use them as function parameters. So if you see a union somewhere, let me know. You don't see them very often these days. And that's all we're going to talk about unions in this class, just making you aware that they exist. We won't actually use them in any of our homework.